Okay, so I trust you've all had a good week. Yep. Yep. And things are going fairly well with the first assignment. Are there any questions in relation to that? People, yeah, people are finding that fairly straightforward. Okay. Yeah. Also, I guess given that we're going to be covering concrete material this week, it forms a bit of a revision for what we covered last week in concrete structure. So, yeah, very important material in construction, been a very important material for a long time. Although it seems fairly simple, there's actually quite a lot of science and research that goes into concrete and making concrete behave in various different fashions. There are a few good resources for you on the Learn site. Actually, I'll just shrink this one down while we're there. So a link here to concrete.net and Cement Australia. But this one here, this PDF, is one of my favourites. It's called Concrete Basics. I'll just bring that up when it opens. It's taking a little while. I'll give it a look. Here we go. Yeah. So I urge you to have a good look at this and download it, grab it for yourself, put it on your own computer. In fact, another thing I suggest you do is start getting a filing system happening on your computer where you're putting together all these resources about various different materials and products. But this is a great reference for I guess, yeah, for just about anything concrete. So concrete materials, concrete properties, testing, ordering concrete, proportioning and mixing concrete. So it's an important thing to understand. Planning and site preparation, transport and placing concrete, compacting concrete, finishing concrete, curing concrete, joints, hot and cold weathering, surface finishes, defects, removing stains, cracking, reinforced concrete formwork. So it's as the name suggests, it's the concrete basics, but it covers just about everything you'll need to know in the beginning in regards to concreting and using concrete. So I suggest have a good look at that yourself at home, but keep that as a resource for yourself. And also, yeah, we've got the link to Cement Australia. So various different publications available on here, and other resources to have a look at. So we know the difference between cement and concrete. Cement's the powder that helps make concrete. So it's the grey powder that we mix in with the fine and coarse aggregates and water to make concrete. So rock-like material typically we use what's called Portland cement, and it's actually a bit of conjecture around that. I initially thought it was named after the place Portland in England where it was first discovered, but I've heard otherwise since. Then coarse aggregate. So this it can be various different rock materials. So you've got your various different suppliers of aggregate, and they test their aggregates to ensure that they have good compressive strength, because both the strength of your aggregate and the shape of your aggregate will impact upon both the strength of your concrete and the workability of your concrete. Fairly rounded Arris aggregates like this produce concrete with good workability, because they can slide around easily. They'll move around easily within the fine aggregate, within the sand. Whereas you can get, this one here, that's a fairly coarse aggregate, or sharp Arises on that one. And then so with the aggregates, and then you've got water, and then various different admixtures to make concrete perform in various different fashions, or to be used for various different applications, be that with exposure to salt water or curing quickly, curing slowly, etc. One of the largest, well, the main contributor to concrete strength is your cement-water ratio. So the more cement you have to your water, the higher strength concrete you have, but typically then the less workability you have of that concrete. It's a fairly standard detail. So we've got slab set down, reinforcing here. So that marriage between concrete and steel, concrete providing the compressive strength, steel providing the strength in tension, works fantastically for producing things such as footings for buildings. You'll also see in this detail 50 mil of compacted rubble, and then also crusher fines on top of that. So that's typically what it will look like once excavation has happened and you've got the plastic laid down and the reinforcing laid down in there. This one doesn't have particularly large bars in it, and they're not particularly deep. It doesn't appear to be a fairly reactive site for this one. But note the diagonal reinforcement across here for the re-entrant corner, because wherever you have a re-entrant corner, you have two levers essentially working against each other, that when we get soil movement, one of the most likely places for this building to crack is in through this corner here in this direction. So that's why we have this reinforcing on a diagonal in the corner. And also note that all the vapor-proof membrane has been taped through there. And here's a clearer view of diagonal reinforcing. This is also a detail you should become fairly familiar with throughout the course. So brick veneer is a very common form of building for us in South Australia. It involves a structural timber frame and then a cavity between that structural timber frame and then our brickwork, and we'll touch on brickwork in the weeks to come. And then that sits on top of our concrete foundations, concrete footings. Also, we use cement powder in the production of mortar as well, between our brickwork, and we also use lime in that to produce mortar. Compressed fibre cement sheet is also another use of concrete with use of cement within building products, and that's becoming, I guess, a little bit more in vogue once again. And also, it's one of these materials, particularly this express jointed fibre cement sheet, is one of those materials that you see used a lot in commercial construction, but then also bits and bobs in residential construction as well. One aesthetic I've come to appreciate is, well, certainly this aesthetic where you have the raw fibre cement sheet. Previously, that hasn't really been an option because of the necessity to seal the fibre cement sheet. But there are a couple companies now that are able to produce fibre cement sheet in an 8mm or 10mm sheet with clear sealers, so sealers that go on and you don't see them, and then produce this raw appearance fibre cement sheet that doesn't grow mould on it. And yeah, so one of those companies is CSR. They produce a product called Bearstone. And does anybody know? I guess everybody knows Whitmore Square in Adelaide. Can you think of Whitmore Square, where that is? Or the Tropo Cafe on Whitmore Square? No. I'll just quickly pull it up. I'll just grab some images. So Whitmore Square, that's right. It's in the centre of the city. Well, you've got Victoria Square right there in the centre where the central markets are, but then Whitmore Square is to the southwest of that. I'll just grab some images. So I think I've mentioned Troppo Architects to, yeah?
I live nearby.
Oh, you live nearby? Right, okay. Yeah. So Troppo Architects, they're an architectural firm that were up in Darwin. So a couple guys from Adelaide originally set up a practice in Darwin and did a lot of work up in Darwin, and then moved back and opened an office in Adelaide. A lot of their style is based around how to say it, that it's kind of sort of North Australian vernacular, use of corrugated iron, lightweight construction, timber screening, and but in this instance, what they've featured also in this building a fair bit is that I was trying to find a good, oh, that's a decent one. So this natural look fibre cement sheet as well. So using that fibre cement sheet in its natural form and expressing the natural form or the natural colour of that. Another interesting use of fibre cement sheet seen recently. Does anybody know the ARC Aquatic Centre on is it Northeast Road?
Yes.
No, yep,
Yeah.
yep. So yeah, so if you go past there or walk in there, have a look at their cladding system on there. But I'll just see if I can bring up some good pictures of it. Let's see. I wanted to get some from the outside. Yeah, it's not quite the best picture I was looking for, but hoping for something a little bit closer up. But on first appearances, you wouldn't expect that to be fibre cement sheet cladding. But once again, it's that express jointed fibre cement sheet. So you've got the 10 mil joins, and that's why you can see these lines through here, etc. But it has a glossy finish to it. So it's used in much the same way, or for much the same sort of design language that you'd use aluminium sandwich panel cladding or so. But this product certainly is a bit more fire resistant than aluminium sandwich panel cladding.
Is it more brittle?
Certainly.
Fibre cement, the Luca bond, you can hit to put a dent in it. You hit this and it would just shatter, wouldn't it?
Yes. Yeah. Now I'm not can't be entirely sure about or providing comment on on impact resistance, but just as at a guess, it'd be more impact resistant than the aluminium sandwich panel, but the aluminium sandwich panel wouldn't split, so it'd dent, and you'd get a dent, whereas this would crack, and so the aluminium you'd have to, well, I guess you could still use it, whereas this one you'd have to replace it. So aluminium, you'd end up having a dent, but I think in the main, if you bang a shopping trolley into this or so, it'd be more hard wearing in that sense. Well, it wouldn't dent, but then for larger impacts, then it would split, and you'd need to replace sections. And so this sort of express jointed fibre cement sheet cladding is also making its way again, I guess, into residential construction, and people are I guess using it in a fairly for a fairly modern aesthetic. It's a composite material made of sand, cement, cellulose fibres, and a few other additives to make it perform. So additives such as waterproofing, uh, like water sealer. It can come in the form of weatherboards, external cladding, commercial facades, internal linings, compressed sheet flooring, bracing, columns, lattice, and can be manufactured or is manufactured with fibre cement. So compressed sheet flooring is used a lot for bathrooms for suspended floors. I don't have any thick sheet to bring in, but that's what it's called. It's quite a thick sheet. I think you get it in 15mm thickness and 19mm thickness. So it's really quite heavy stuff to carry in. I mentioned thick sheet in one of my lectures previously, and one of my students was a carpenter, and he said, "Oh, I hate using it. It's so heavy, so terrible to carry in." But it produces a good floor for wet areas, because in wet areas we can't go using timber or any and certainly we can't go using things like structure floor. And also gets used for wet area linings as well. Fibre cement sheet for wet area linings because of its water resistance. And various different products for bracing as well, but typically it's fibre cement sheet's not used for bracing, but it has a bracing capacity, so it can be used for bracing to help shore up a house. But typically when we talk about sheet bracing, we're using things like plywood and OSB and masonite, which I'll show you a little bit later on. Some more applications of fibre cement sheet external cladding. And I guess on that, I assume everybody's aware of asbestos cement sheet cladding as well. Yeah. So from the outside they can look very similar, but asbestos cement sheet cladding, I don't have any here to show you. I probably shouldn't go bringing it in to TAFE anyhow. But it's a harder it's a slightly more brittle material than your standard fibre cement sheet cladding, and it also has this dimpled golf ball looking backing to it as well. You've seen it before, yeah. And that I guess has in a sense sort of tarnished that name of or the appeal of fibre cement sheet cladding as well, because there were a lot of buildings built in from the 1930s through the 1970s that used asbestos cement sheet cladding, and then there's difficulty on working with those buildings, and also in removing, and a lot of expense in removing all of that asbestos cement sheet cladding. I showed you a bit of aerated autoclave concrete last week. So Hebel, that's the brand name of the supplier in South Australia. So manufactured from sand, lime, and cement, to which a gas forming agent is added. So it's like an aluminium oxide that when it's put in contact with the cement powder, it foams up and makes air pockets within that cement or within that concrete. So during manufacture, the liberated gas expands the mixture, forming extremely small, finely dispersed air pockets, resulting in the finished aerated concrete. And then
Hebel's been around for decades now. And it's got so many advantages. Why hasn't it put bricks away with the dodo?
Well, because it's a different aesthetic. So one of the things that I have continuously noticed about architecture in general, well, not architecture, but certainly your residential architecture, your residential building design and taste, is that there is a lot of conservatism within buildings. So people do like the look of bricks. They'll go, oh yes, I want a brick building. I want that building to look like this. Certainly there has been a far more a far greater acceptance of rendered facades and so on in buildings. But I guess also that idea of rendered buildings was also a little bit tarnished by some of the, particularly about sort of 15, 20 years ago, a lot of buildings were sprung up using blueboard cladding and then rendering over the blueboard. And then, 5 or 6 years later, because of the inflexibility of those sheets, well, the inflexibility of render as well, but then you had flexible joints, you just had cracking happening in sections, and so you had rendered buildings that aged very quickly, and so that's I guess sort of tarnished that appeal of a rendered building, and that's pretty much all you're going to do with Hebel. So when you do a Hebel wall, the intention is that you render the outside, or typically the intention is that you render the outside, because you have to weather seal that material. I've never actually seen a Hebel wall left simply as a Hebel wall. Yeah.
Yeah, good look.
Yeah, yeah. Well, I don't know how it would perform, but I imagine it, being a relatively porous material, it'd harbour moisture and start growing some mold and things like that on the outside. That's my hunch on that. But another reason why Hebel isn't used, so beyond just beyond taste and desired aesthetics, is that it's also quite expensive as well. So I think Hebel is a fantastic flooring material. It's amazing. You get your 150 thick sheets of Hebel flooring, and they'll do a 6 metre span. Like that's with no load bearing, no point loads between that span, of course, but for just a flooring span, and that's amazing to do really big spans for flooring. Except it's quite expensive, and that's the issue. So that
Is it expensive when you if you're designing a house and you're sort of saying, okay, I've got a 2-story residence,
yeah,
and I'm going to do a 6 metre span, and I'm tossing it up at the moment, and then you say, well, okay, I'm going to put timber flooring, okay, and a timber floor is real timber,
yeah,
okay, not making something like about $180 a square metre, for the hardwood I was looking at. And then you sort of say, well, okay, if I've got Hebel, I've got a soundproofed situation,
yeah,
I've got an insulation situation. All I've got to do with the Hebel is then effectively put a slurry over it and tile it.
yes, yeah,
Okay, or you could just put a thing and carpet over the top of it.
yes, yeah,
They're really cheap. So then you work out your cost back. It's about even.
yeah, yeah,
If you sort of said $50 a square metre of tiles, which is what I was looking at, 75 a square metre for the Hebel, and then labour content. Once you've got your timber down, you still got to finish it. You've got to maintain it.
yeah,
Everything else. If you put the Hebel down, you can also whack underfloor too.
yeah, yeah,
So
yeah, yes.
It's sort of it's a bit of a burden.
Yeah, yeah. Okay, yeah, yeah. No, it is certainly there's a point, and also because there are savings in the structure, and you've got to look at, okay, so how do those savings carry through, and you've got to also look at the benefits as well. But if we were to do quite a, if we're thinking about doing a cheap house, well, cheap house, I mean, like, a house on a budget, as many houses are constructed. We were to get, and I'll show these a bit later, but these type of things, there's floor joists, so engineered floor joists, and then I don't have any structural floor bits here, but then structural floor on top of that, it does work out quite a bit cheaper than doing Hebel power floor. What you get though with this sort of flooring system is you get flexibility, you get noise carrying through the floor, like you mentioned. don't have that sound insulation, and you have a different floor feel. Like the Hebel gives you a very solid feel to your floor as well. So there's a bunch of benefits. But when it comes down to, okay, we can build this, we can do this house for 220 or 235. People go, oh yeah, I go, oh that's yeah. And so that is the option. But yeah, when you're going beyond, I guess, the bare bones cheap, well then and you start looking into its benefits, well then certainly it makes sense, and certainly in comparison to things like suspended poured concrete floors as well, because there's a lot of expense in those as well. So. But yeah, there are still quite a few Hebel buildings, well, Hebel clad and Hebel floored buildings going up, and also it's really good material for doing fire separation walls as well, like intertenancy walls. I mentioned right at the start that if you were to build a building today, a block of units, you would put firewalls in between. Well, you'd have to put firewalls in between them all. So they're classed as sole occupancy units. Otherwise, they're just the one occupancy, and you couldn't rent them out or sell them off separately. So you've got to have a wall that separates those buildings, that has the ability to stand up to fire for 3 hours, so maintain its structure, maintain its integrity, so fire can't breach through that wall, and also maintain its insulation, so the heat from the unit burning next door doesn't make it into your unit. So you've got to produce these fire separation walls, and Hebel's another way of doing that as well. Certainly you can there. Many internal lining manufacturers produce details to make fire separation walls with simple stud work and then several layers of fire resistant internal linings. So 2 layers of fire check either side with insulation in your walls. But another way of doing it is to have 2 stud walls with a gap in between, and then do Hebel sandwich in between those 2 walls and glued together to produce that fire resistance as well. So that's another use of it.
So are you saying like you've got 2 lots of Hebel and an air gap, or the stud wall either side of the
stud wall either side of the Hebel? Yeah.
So you just have 1 Hebel block and 2. Because around the corner we've got 3 units going up.
Yeah.
And it's just Hebel between one Hebel wall between them.
Right, and they don't have any stud work either side of that?
Well, there will be stud work between them. Yeah. But yeah, when you look at it, it's only the Hebel slab that's really the sound deadener. The rest of it's just villa.
Yeah.
So, it's not a really sort of big structure between the actual houses when you think about it.
No. But what they have to do, and what you want a building to do in a fire, is you want, if you're using timber or steel, like gauge steel construction, if you have a fire, what eventually happens is walls start caving in and things start falling in if it's a very intense fire. What you don't want happening is sharing of any structure between a neighbouring unit. So if you have your timber stud wall, the same way you'd have, so here's our timber stud wall here. If we have another timber, so that's on our outside, our adjoining wall should be pretty much the same as that, but then we have a fire separation material like Hebel, and then we have another timber stud wall on the other side to enable those 2 to act independently and work independently. So if one burns and collapses, you still have that Hebel wall standing, and you still have the timber frame of the next unit standing uncompromised. Yeah, because that is I guess that's one easy point of fire encroaching is particularly when you've got multi-story or you've got a suspended floor inside, and then that floor burns and the floor joists fall down and take a chunk of wall with them, and then the fire can go into the next unit. That's what we that's what you want to design to avoid. Part of what you want to design to avoid. So that's another use. Also Hebel block. I haven't seen people using Hebel block for a while now. Has anybody seen that being used? You have?
Yeah.
Yes.
It's 3 units on a block of Campbelltown or Paradise, and everything is the Hebel panels, Hebel bricks, a whole lot, and it's incredible. The storm water, the pipes actually come inside the houses.
Oh yeah.
The houses in a sort of like a pantry, the storage area.
Yeah.
With inspection covers, and it's interesting how they've got around a lot of the stuff, but you know, it's actually boundary to boundary of just Hebel wall.
Right. Okay. Yeah.
You know, they've used every millimetre of the block.
Yeah. But then used a whole bunch of, so they've got got power panels and they've got blocks in section.
And you can obviously see,
Yeah.
you know, to lay brickwork, you would have had to get agreement from the neighbours to be on their site. Like
Yes.
this
Yeah.
was just nice, easy. They just put the panels up, and you know, it would have saved them a lot of time as well.
Yeah. And actually, and on that, it's something I haven't prepared any slides on or introduced to any slides because it's still, I guess, well, it's a little bit new. Have all of you heard of ICF before? ICF, no. So that's another, and I'll digress a little bit and include that in this as well because it's certainly very important for concrete.
We talked
So-
about those foam blocks. in
Yes.
Caulfield.
Yeah.
Yeah.
Oh yeah.
It's a lot in Western Australia.
Yeah. I don't. So what? Yeah, maybe I'll have a look for a closer detailed picture as well. But what it is you've got a series. They look like like Besser blocks essentially, like concrete blocks, except they're styrofoam hollow core that they slot on top of each other. And basically, what it does is it provides a formwork for the concrete to be poured inside. So the concrete gets poured inside this styrofoam formwork and then forms up the wall. So you've got a styrofoam insulation layer on both the outside and the inside, and then that is either clad with various materials or a render is applied on the outside. That's another. It has its limitations. So for building bushfire prone areas, there's some limitations around using it there. And I guess essentially, I think it's not a particularly environmentally friendly material as well. You end up having a whole lot of you've got styrofoam, but then also concrete has a high embodied energy. There's a lot of energy that goes into making cement powder for producing concrete. And certainly I think concrete for slabs is fantastic because you're using that thermal mass of it. But when you're actually hiding your thermal mass behind an insulation, you're not getting all of what you could out of that embodied energy initially.
Yeah, it's perfect for making your wine cellar.
Yeah.
I think that's, I've looked at it and thought, oh, yeah,
Yeah.
do that in my backyard.
Yeah, yeah,
Yeah.
yeah. And also I think, and what made me think of it quickly was you mentioning that boundary wall. So it's perfect for things like boundary walls, where where you won't have to gain access to the neighbour's property, because you're just slotting in these styrofoam formwork, and you fill it with concrete, slot some more in, fill it with concrete. And on that, also the way that this is done, it's important to abide by the manufacturer's recommendations about lifts of concrete as well. You don't just build the whole thing up and then fill the whole thing full of concrete, because when concrete is in its plastic form in a slurry, it has quite a lot of head pressure, and so it can blast out the blocks underneath. And on that, also, that's also very important to be aware of any sort of core filling as well. We had to specify a curved brick wall that was core filled, and the concreters the bricklayers built the whole thing up, and the concreters just poured all the concrete in at once, and being curved, it just blew out, because you have that compromising of strength by the curve. So it should always be done in certain lifts, like so 1 metre interval and another metre interval, like that, and that's the same with the ICF as well. Yeah, but we'll get back to our fibre cement sheet. Oh, and then another significant use of concrete in buildings is tilt-up panel construction. Can anybody tell me the difference between tilt-up panel construction and precast panel construction?
In Moslake they have a foot length, like the supermarket.
What's that? Oh, in Mawson Lakes, they
Yeah,
got it.
yeah.
Yep.
And I saw that they use it.
Yep. Yeah, so it is a particularly good way. Yeah, it's used a lot for supermarkets, etc., and warehouses as well. Anybody think why you'd be able to lease out a warehouse that's tilt-up concrete for a lot more money than you can for just a steel-clad portal frame warehouse?
Security's good.
Security, yeah, because and
maximum floor space too.
yeah,
Because when you're talking about tilt up like that,
mm-hmm.
the tilt ups by their roost band effectively secure
Brace,
the structure
yeah,
from falling down. So you've got wall to wall, as opposed to in a lot of places having posts holding up the ceiling.
yeah.
So
So yes, that uninterrupted floor space, but the big one is security. For the
when it
warehouses.
first started, I noticed that most of the, like there was precast and they brought it in on the truck.
Yeah.
But a lot of this tilt-up was actually, once the floor was poured, that was the mould for the tilt-up. And they just used purlins that just used as a former, poured the concrete, put a bit of plastic on the next one, poured them on top, or they just put them along where they need them. And then when they cured, they just tilt them up.
Yeah, exactly. And that is, you struck the nail on the head. That's the difference between tilt-up and precast. Is that tilt-up happens on site, precast happens at like at Bianco Precast or so out at Cabin. These tilt-up panels, they're cast on site. So you cast the floor slab first, and then you cast. Yeah, sometimes, as you're saying, you cast them in a line, and if you've got lots of space, you do that. If you don't have a lot of space, then you cast them on top of each other.
the tilt ups that I'm getting the market.
Yeah.
Sitting up on Lonzo.
Yeah.
He's got a big SA tilt up. It'll be as long as his tape. His factory.
Yeah.
With a big conveyor that goes along
Yeah.
the truck.
Gantry crane. Yeah.
Then they stack them up.
Yeah.
And so, mine have been sitting there for 3 weeks.
Yeah. And there's certainly benefits to producing like precast as opposed to to on-site cast tilt up, in that you can have much better quality control and really good beds for forming everything, and much better finishes.
Yeah, he grades finishes. I mean, I could literally, if I wanted to, I could have had a polished cement around the outside area, but we didn't want that.
Yeah.
You know, his range of price went for 150 mil thick.
Yeah.
At, as in like a raw finish.
Yeah.
Was 150 bucks a square metre.
Okay.
To a class B finish, which was fairly smooth, sort of that sort of smooth.
Yeah.
That was 200 a square metre.
Mm-hmm.
And then to go right up to the top grade was 250 bucks a square metre.
Okay.
So,
Yep.
you know, it's sort of seeing we're putting a float on a tile.
Yeah.
We said, look, you know, just the cheapest. At 150 mil. So.
Yeah. Yeah. And so that's going to be your floor slabs.
That's going to be part of it.
But yeah.
There'll be a 75 mil topper. On top of that, that'll be the outside gantry and deck.
Yeah.
On top of that, in the outside area, the inside building, we've got to put another 75 mil that floats and takes it back into the main structure.
Yeah. 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 And so with that, you also were you able to get a variable thickness in your slab as well, or it's just the one thickness? And so
one thickness.
Yeah.
Because say where your joiner lines are there.
Mm-hmm.
Okay.
Yeah.
Let's just say the steel formwork there was from there down to ground level was sort of inside the house bit.
Mm-hmm.
Okay. Where those joiner bits are, it's actually we've got exposed down a little bit, the Rio exposed.
Yeah.
So that when we pull the floater, we've got steel ties going into that Rio.
Yes.
And tying all the way back into the garage area, which is, you know, structurally holding all that up in the air.
Yeah.
So besides the two columns.
Yeah.
So it's sort of, it's not, that's why we didn't need to have, you know, pretty. It's just function.
Yes. Yeah.
He'll do amazing things with it. A good example of tilt up in the walls for the house, there's a bloke in between on the Esplanade, Port Noarlunga.
Yeah.
So there's the Port Noarlunga jetty coming back up the hill from Port Noarlunga jetty.
Yeah.
Virtually at the top of the hill, there's a bloke there that's used tilt up in all sorts of crazy angles with windows.
Oh yes. Yeah.
And sort of, I suppose that's sort of half of what the idea.
Yeah.
To use the pedals in the lay-down scenario. So you know, I was watching his house. I was sort of like, okay, there's some radical angles of tilt up.
Yes.
The thing, he's made a feature out of the raw cement.
Yeah.
Tilt up.
Yeah.
It's cool.
Yeah. Yeah. And that's I guess that's gaining a lot of acceptance. Is, you know, the idea of the beauty in concrete, the, you know, that raw finish, or off-form concrete as well. I think I mentioned that last week. When you express the grain in your timber formwork into your concrete. Yeah, cool. So a bunch of uses, so residential and commercial for your tilt up concrete. It can happen very quickly. Obviously, a very important aspect of consideration in the design is access for cranes and access for trucks. So if it's going to be precast concrete, whether you're going to be able to get those precast panels there easily, or, you know, and whether you're going to get them put into place very quickly and easily. I think I may have mentioned this last week. I did some reinstatement work for a place at Freegon. Freegon is right in central Australia, and sort of, well, still a few hundred. I think it's maybe still about 400 or 500 k's from Alice Springs. So a supermarket there, like a very sort of like a general store supermarket type thing, had a fire in it, and one of the precast panels got damaged. Only one needed replacing, but that's the real difficulty with something like this, is that if it were just another form of material that you can truck all the bits in there on a smaller truck, like a masonry wall, and you build that up, or timber stud work or so, and you build that up, or sheeting, and you attach new sheeting, etc. It's fairly simple, but when you've got to replace just one precast panel in Central Australia, it means you've got to get this precast panel made, taken all the way up there, get a crane from somewhere, get that in there as well to do a very quick job, and then it's paying for the transport, all that stuff back out of there again at $500 an hour is very expensive process. So certainly in scenarios like that, there can be issues with repair and reinstatement with it, but that's probably about the only sort of significant issue I've seen with that product before. Various different ways of fixing them and lifting them as well. So these panels, they'll have lifting lugs cast in. No images of lifting lugs. I'll do a quick cross section through a panel to show you what a lifting lug looks like. So we'll say, for example, that's our precast panel, and then we have a section in there which is formed up and cast as an accommodation for this steel lug, like that. So, and then in elevation, it looks much like this. So we need to be able to lift these panels, and so you cast in little steel lugs like this for lifting them up, and then when everything's in place, that gets flushed over with some grout to hopefully disguise it and make it look the same. And that's another issue with precast construction, is if any defects and so on happen, it's very hard to have a seamless appearance. Down at the base of your panels, several different ways of fixing them in place. One way is by having, so you have your concrete flooring here like this, and then you have very thick starter bars that are cast into your concrete floor, probably with a cog on the end of them. And then the base of your panel has a larger accommodation for that starter bar, and then a little grout tube going into there, so that you can slot your panels onto these starter bars and then pump this area full of grout to fix around those starter bars and get your panels fixed solidly in place at the base. So if vehicle impact here, it's not going to shift in. That's one way of fixing them in place. Another way I've seen is, and I guess this is certainly preferred method. The other way is to have a large equal angle here, like a 5mm thick equal angle that's fixed to the panel and fixed to the floor. Also provides that strength at the base. Certainly doesn't provide much in the way of any overturning strength, but all your overturning strength happens from your roof structure, from that roof structure tying the panels together.
Yeah,
because
that grout actually expands when it dries. But does your normal concrete, when it dries, expand, or does it shrink?
No, it shrinks. Yeah. So I've always specified it as non-shrink grout. So you've seen it. You've
Yeah.
seen grout that expands.
We've got it where balustrade posts go into a core cut hole,
Yes.
and they just pour the mortar in,
Yeah.
and it just grabs it, and you can't pull it out.
Mm.
It's absolutely solid because it actually just expands that little bit.
Right. It's actually slightly expansive. Just either of you had. Yeah. Yeah. What's that?
Oh, I was for the balancing.
Oh yes. Yeah. And it expands slightly.
Yeah.
Yeah. Right. Cool. And what work is that for doing?
Residential.
Yeah. Yeah. In.
Put
Yeah.
huge columns in the starts like that and put the non-stream cloud in.
Yeah. 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 So it's called non-shrink, but it actually expands slightly.
Still,
Yeah.
instead of having the posts with the plate, goes in the hole.
Yeah, well, in my tilt-ups, that I've got to do, I've got come in 150. But, so, yeah.
Yeah. Yeah. And yeah. So you got some interesting fixing details with your.
Well,
tilt-up?
I've got to draw.
You got to draw them, right?
I've allowed 150 in, and I've had the bloke starting tilt-ups not put any Rio at that point, so that when we drill, we don't hit the steel bar.
Right. Yeah.
So that we can put in the legs for the balustrade.
Oh yes.
So originally I wanted wire balustrade, but because I'm so high, they said no.
Yeah. Yeah.
I've got to have glass, and I didn't want to have too many posts, so
Yeah.
in fact I'm having no posts, so it was sort of like, okay, get the posts studs, and then I've spoken with the balustrade bloke, and yeah, so we've got all the, once that's up, that's
Yeah.
one of the first drops, is to core and seal the band. So I was
Yeah.
interested in that it actually expands, because
Mm.
Yeah, it surprised me.
Yeah.
First time I've done it, and I've run it.
as he was talking about, also having bolting these, plate bolting, like that, I wanted it to be
Flush and
flush and straight.
neat. Yeah. 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 Cool. So there's the non-shrink grout option or the equal angle option, and typically what I've seen at the top of panels, tying them together, is your equal angle here at the top, like that, and that will, and for in elevation, but on the other side of this lifting lug, we have our top angle, equal angle fixed along there like that, and shares between panels. So those panels tie each other together at the top, and then that becomes a fixing point for, let's say, some roof trusses or so we can fix into that to provide rigidity to the structure.
I've often wondered, with panels like that,
Yeah.
and that whole situation, Australia not being an earthquake zone, we're pretty fine. But imagine if we were an earthquake zone, how they'd stand up
Yeah.
to an earthquake.
Yeah. I don't know.
They don't stand up to a storm because I remember years ago building one of the first tilt-ups that was on the corner of Grand Junction and South Road.
Mm-hmm.
And they got to that stage of putting it all up, and the storm, that was Friday. Saturday, the storm came in and it just fell to pieces. It was like, your decker card type houses.
Wow.
It was just strewn all over the place.
Yeah. So very expensive and very dangerous
Yeah.
scenario. Yeah. So they've been fairly generous with their temporary bracing in this example, and maybe that's sets the case for that. So you have factories in where the panels are cast. So on casting beds. So it enables a little bit more efficient use of concrete, but then also a bit more efficient use of materials and so on, because any wastage is reused, and you've got that quality control and produced in an environment where you're not going to have rain, you're not going to have a lot of heat. So a whole bunch of shapes and finishes possible with precast. However, that's your typical sort of use. So we've got some intertenancy walls there that provide the structure for the units. So we see some patching on here. That's where they would have had lifting lugs for those panels to lift them in place. Also, an architectural innovation from, I don't know, was it probably about the 1930s or so, is the use of concrete columns and beams or suspended concrete floors as well. It was I think it was it Le Corbusier who pioneered the use of this to be able to open up spaces, and that's still the way things are done for a lot of a lot of high-rise office buildings today. So it enables the inclusion of curtain wall glazing, so glass from top to bottom, all the way along, or other walling solutions on the outside, and a fairly uninterrupted floor space inside. And that's what we've got here at the tank as well. You may have noticed. So this structure built inside this old structure, based on concrete columns and elevated or suspended slabs. Not widely used in residential construction, but still, possibly in your top.
Our first tilt-up was actually residential. It was in Prospect.
Yeah.
Back in the early 50s, where I think there was a residential spec builder and built the display homes there, and it was all done on the very first tilt-up system.
Yeah, right.
And people absolutely hated it, and they stand out because you can see that they got that stick-on brick veneer to hide it.
Right. Okay.
Yeah.
Yeah.
So that was the very first tilt-up, way back in the 50s.
Okay. Do you know what the address of that place is?
Yeah, I think there's one down La Hunt Street down in Prospect. Yeah.
Yeah. I'll just quickly have a look to see. So we go.
It's in the wild part.
Yeah, down on the Kilburn side.
Yeah.
But they're becoming
So
collectors.
they're all bungalows up top.
None of those. No. Yeah. Might have a look around for it. So La Hunt is spelled like this, isn't it? Lehunte.
Yeah.
La Hunt Street, Prospect. Yeah. Didn't have anything pop up in the first page, so yeah, we won't spend a lot of time looking for it, but I'll have a look for that later on. So concrete used significantly in high-rise construction, and also, as you would have noticed, in roadworks and freeway construction. Also, so in this building here, it's in Melbourne. Does anyone know? It was called Eureka Tower, was it? Eureka Tower in Melbourne. So once again, a structure of concrete columns and suspended floors, but we have a central lift shaft leading the construction. So that concrete lift shaft with slip form. So they have a form, it gets filled with concrete, and then once that's cured and hardened, moves up, do that, moves up, do a bit more. So their slip forms go up like this, and so you have your lift shaft leading the construction of the building, creating that that internal concrete spine, so to speak. Some other uses of concrete. So got our concrete blocks, so Besta blocks, and then also cement render on the top. And some interesting uses of concrete there. Concrete can be formed into almost any shape. One of the most impressive uses of, or what I think of concrete is skate parks. Anybody into? Yeah, I find it really quite impressive the concrete work that it's not there anymore. That skate park across from City West campus near, was it Morford Street Bridge?
Yeah. Old Lions Flower.
Yes, just near there. So just some amazing concreting work going into that. To use that. So all sorts of shapes and sizes. That I'm not sure how this form of construction is built, but from what I know about the construction of things like skate parks and swimming pools, is it's shock-fired concrete. So you have your steel mesh in place, and then you just shoot the concrete into it, and it sticks on there, and then it's troweled off into your various different shapes.
Like the Flintstone house. That was actually sold a couple of weeks ago for $3 million or something.
What's the Flintstone house?
Haven't you seen the
No.
Flintstone house?
Look at that one.
It's a proper. I'm trying to think who it was. One of the television guys built it in America, as like the Fred Flintstone movies, and it was only sold a week or two ago.
Is this it? That one maybe?
Yeah, well that's the cartoon version, but there's down about 3 rows down, second in, where the kitchen. Yeah, that one. That one looks like it. Part of it.
Oh,
Yeah, that's it.
that's it there. Yeah, wow. Yeah. So
Everything's formed out of concrete.
Yeah. So I guess once again shot fired, or probably shot fired concrete. So anybody actually, I don't know much about Magic Mountain because I didn't grow up in Adelaide as a kid, but I think that would have been produced like that as well, wouldn't it? Does anybody know about the construction of Magic Mountain?
I think it was more fiberglass. Yeah.
Right, it was mostly fiberglass, was it?
It was just on a steel framework, and it was just sort of all well, instead of concrete being sprayed, it was chopped fiberglass.
Right. Yeah.
Got windy in certain places out here, full area.
That's why it was so easy to pull apart. It was hollow, and so there wasn't much weight to it.
Right. Okay. Yeah. Just from the outside, it appeared to be that concrete sort of thing with just
one of my
fiberglass on the
friends
shell.
had their pool done with this, and like you said, it was just like spray paint. They just put it on there. He was absolutely shocked with how it just stuck there and it didn't fall down. It was just like spray paint in a swimming pool.
Yeah. And on that as well, has anybody heard of glass fibre reinforced concrete?
Yeah. That's used. I've seen a lot of it used for inspection covers and tubs.
Yes.
And that sort of thing. And now a lot of it's sort of plastic fiberglass reinforced as well.
Yeah.
But for some reason they're using a lot of glass fibre to reinforce everything now.
Yeah. Maybe because it doesn't rust. Personally, I haven't used it, but some of my family who are doing construction of stockyards, we're using it for concreting in posts and steel members because it doesn't rust. So you use the glass fibre as a reinforcing of the concrete, so you get that reinforced concrete, but without the entry of rust because you get
It must probably be perfect around near the sea.
Yeah. Yeah.
Because apparently there's a big stigma. A lot of people that are like working with, man-made, what do you call it, like Caesar stone and that sort of stuff, or
Yes.
class 5 granite.
Yeah.
The dust from that actually is really bad for your lungs.
Right.
And it kills you.
Yeah.
It actually creates pockets. So, that class 5 stuff and cement, if you're ever cutting it, you've always got to have it water.
Right. Yeah. And also it was quite a while ago I saw there was an architect. Actually no, he wasn't an architect, an engineer who built a place in Stonyfeld here in Adelaide with glass fibre reinforced concrete walls.
I've been to the house and visited him because I was actually going to use him as an engineer.
Right. Yeah.
And he didn't want to touch my project.
Right.
He actually, he's
Not enough glass fibre, is it?
No, at that stage, it's on Grand Design. It's
Yes.
his house.
Yeah.
It's called the Waterhouse.
Waterhouse,
And
right.
his roof, he designed his roof in the house on 2 water tanks. So it's actually, the house is cantilevered off these 2 water tanks, and they're steel tanks. And he actually made his own factory class 5 of the house. And the roof, while the roof looks like a normal hipped roof, the hip of the roof is all mesh, allows the water to come through, and sits inside the 2 tanks. The 2 tanks, the wave embeds themselves on the ground, and he built the steel house around. Very clever.
Yes. Yeah.
Very clever, and it just looks like a normal suburban house.
Yeah. So the Waterhouse is what it's called. The Waterhouse.
It's called
Yeah.
the
So
Waterhouse.
it's
On Grand Design.
yeah, on Grand Designs.
Yeah.
Yep. Yeah. But
He also engineered Adelaide Oval.
right.
He was the engineer called Steel.
Okay. Yeah. Yep. So this is we can flick through this all fairly quickly. So we've seen a lot of this stuff already. So this is the placing of concrete. So we've got a concrete pump with a boom to enable concrete to be easily placed. So when you're using a boom, have the pipe hanging down. We're not having to barrow concrete, not having to lug it through whatever. And that's pretty much the mainstay of placing concrete now. I think you'd be hard pressed to find concrete that doesn't want to barrow concrete into place from a chute on a truck. So we've seen a lot of these images before. So our internal beams, our mesh, our Termi mesh around the pipes to stop termites coming up, because the concrete, when it goes off, it shrinks slightly and creates that gap. So the working of the concrete down into the beams first, and then the trailing power float on top. My understanding that the bull float is actually the float that's on a very large pole, and you work that by hand. That's a power float. Wet area set down. Cement powder has to be stored correctly because it reacts with moisture. You don't want it to have any exposure to moisture, and also you don't want it coming into contact with eyes and skin and so on. Some people particularly are fairly, how do I say it? Their skin reacts to the cement powder, so it can be quite an irritant for some people. But even just for the majority of people, it really dries out your skin. Concrete is tested particularly for major projects, so you won't often see concrete testing happening for your standard residential stuff, but for major projects it's tested, or for when concrete manufacturers, whether your suppliers, say like Boral or Hallett also, when they want to keep quality control and keep testing their concrete and their aggregates, they'll take samples from a mix. And so those samples are done in a standardized form. So all of those concrete cores are the same size. So samples taken, and just like when you pour concrete into beams, etc., you have to vibrate it down. It has to be rodded into your samples as well. and then those samples are flushed and taken so they're all an accurate size. So they're weighed and measured. Check for size. No one's got a few air pockets, I noticed. And then cured in a controlled environment, so that way they know all the bits of concrete are curing the same. So temperature controlled. And then the samples are crush tested to see what compressive strength results from that particular mix and that particular aggregate. Also, you got samples taken for shrink testing as well. So with little metal ends in them to accurately work out exactly how long they are and what the shrinkage has been. And then also ongoing samples for checking the density of coarse aggregate.
Yeah, with the concrete,
Yeah.
what's always sort of got me with the use of the reinforcing,
Yes.
like, you know, you to 20, 25 MPa, you're going to use reinforcing. But people sort of say, well, you go to 45 MPa and you can do away with the reinforcing. So why don't we all just use 45 MPa?
Because that statement about 45 MPa you can do away with reinforcing, it's not, how to say it. The steel performs a different function than the concrete. Steel is really, like, if I get, so let's say for example, so we've got this concrete block here, this one that they've snapped. So they've got it in a machine and they're applying pressure to it and they're trying to get it to snap. You won't be able to do that with steel. You know, you apply pressure like that with steel, it'll bend and it won't snap. If you add some steel bars into this concrete, then you won't be able to do that as well. Because as you try to snap that concrete sample, the steel bars that are cast in, well, they'll stretch a little bit, and you get some cracking with a lot of pressure, but they will hold that concrete together, and they will give the base of that thing a whole lot more strength in tension, and so concrete's really good in compression. So if we go saying, oh, let's use 45 MPa concrete, that's a higher compressive strength. That means that so I get some 20 MPa concrete and some 45 MPa concrete, and you know I apply suitable footlights. You know, let's say I apply 35 megapascals of force onto that. Well, then the 20 MPa one is going to crush, whereas the 45 isn't going to crush. But that's because of its strength in compression. But yeah, the steel provides that strength in tension, and yeah, does that sort of answer that fairly well? Yeah. So, and also because things like 20 MPa and 32 MPa are your standard sort of mixes as well, and I don't know what you'd have to spend for like 45 MPa concrete, but I imagine it's pretty expensive. Does anybody know?
300.
Yeah.
And also that testing had a big competition in the world because they called the ASTM, this is the International Code about the concrete. Many students or lecturers who study for concrete, they attended in this competition to make sample result to advertise in the world. If you adding different type of the cement and soil together, you can make that type is the best to get more pressure.
Yeah. Yeah.
I was in the one competition, but I wasn't successful.
Right, that's where these slides are from.
Yes.
Yeah, right. For that competition to find the strongest concrete.
Yes.
Right.
Wasn't on that strong concrete? I was reading the thing about the strongest concrete that's ever been made is like in Roman times.
Yeah, using volcanic ash.
Using volcanic ash and seawater.
Mm.
And I didn't get to the guts of it, but why the volcanic ash and the lime? It's incredibly strong. It's lasted centuries. They can't replicate it.
Yeah, right.
There's this concrete, and it's like it's off the charts in strength.
Yeah.
Frustrating.
Yeah, right. Well, I wonder why they can't replicate it. Maybe because they can't dig up some
Oh, they
stuff
still
that they've
trying,
used.
they haven't given up on it. They,
Yeah, right. Yeah.
You know, it's like, it's just incredibly strong
Yeah.
and
Yeah.
like, and the crystal, what they call it, crystalline structure.
Yes. Yeah.
The concrete.
Yeah.
Okay, when they X-ray the concrete, it actually, as it ages, this concrete, the crystalline structure gets even stronger.
Yes.
And they've watched the crystals in the concrete over the years grow.
Yeah. Yeah.
It's incredible.
Yeah. And well, that is with our modern concrete as well. That concrete does get stronger with age. That the longer it cures, the stronger it gets as well. And so so it is continuously gaining in strength, but it's sort of one of those curves where it gains in strength a lot and then that plateaus
This
out.
doesn't, this just, as it ages, it just keeps on
Yes.
going.
Yeah. Yeah, I must have a look at that as well. So I've got to check out the first hilltop place in Prospect and Roman concrete. So lots of aggregates are tested before they go on the market as well. So that's thank you, Boral, for those slides. I'll just go through this fairly quickly. But so research has shown that 5 and 10% of construction, between 5 and 10% of construction workers may be sensitive to cement. So exposure to the skin can cause both irritant and allergic dermatitis. So an allergic reaction to a component in the cement. So subsequent exposure to cement can lead to repeated episodes of dermatitis, which in turn can lead the person having to leave the industry. So it's important to not expose yourself to cement powder or minimise your exposure. Where components in the cement or any additives to concrete mix are classified as hazardous substances, the supplier of premixed concrete should prepare and provide material safety data sheets which contain all relevant information. So is everybody familiar with material safety data sheets, MSDSs? So that's for any hazardous material. Anything you buy, like so you buy some weed killer or something from the hardware store, it should have that material safety information to go along with it as well. Wet cement can also cause burns when trapped against the skin. I never experienced that one. So has anybody had any experience with concrete heating up, etc.? Yeah, I haven't. Yeah, I haven't had that either. Had certainly had had hands and feet and so on working concrete, but never getting that hot. But so barriers intended to prevent contact, such as gloves or boots, must not allow wet cement to be held against the skin. And regular washing with soap and water is necessary to remove cement from the skin. And there's just some hand signals for the boom operators as well. Okay. So what I'm also wanting to do to keep us pushing ahead with structure and materials is also quickly get on to timber, the material as well. So remember the links in here, and also while we're onto it, while I see it in front of me, is everybody keeping up with the quiz? I haven't gone in to see who's doing the quizzes and who's not. Is people are doing the quizzes? Yeah, it should be fairly simple and straightforward. So once again, in the timber material section, there are a whole heap of resources. We won't go through all of them. A lot of this is actually repetition. So in the timber material basics slides, that includes a lot of information which is in some of these other slides as well. Go in there, have a look at them, particularly for once the assignments are up there and you get stuck into the projects. There'll be some handy resources in here for you, but we'll focus on these first two. So timber the material and then making timber durable as well. and then also have a quick look at termites. So yeah, like concrete, it's a material that's been used in construction for a very long time. Probably, I guess, essentially longer than concrete. So it's it's one of those easily available materials that enables spans and supports. But it is a natural material, so it comes, obviously timber comes from trees. How do I say it? The properties of that timber are going to reflect the species of tree and the growing conditions that tree experienced. Has everybody here, or has anybody here heard of CLT, cross-laminated timber construction? Yeah. So that's, and I'll probably pull up a bit of that next week. But that's essentially like giant pieces of plywood for making walls. So some really big. So this is an LVL. And we'll bring everybody up here in a little while. So CLT is kind of like that, same sort of concept. It's lots of bits of timber with grain running this way and then grain running this way, all glued together to make walls. It can happen in a factory, and all the doorways and penetrations and so on, CNC cut, and then the whole thing just bolts together.
What stops the moisture getting in? I've seen it because it's used as just like glue board everywhere on houses now.
Oh, that might be OSB.
No,
No?
it's different stuff.
Yeah.
I looked into CLT. There's two companies. There's a big German company that does it. So
Yeah.
I'm debating on whether to use CLT
Yeah.
or the tilt-ups.
Yeah.
And there's a company in New Zealand. Bloke that was the rep from Australia to New Zealand is now gone into the business himself in Melbourne. And effectively, imagine it virtually like plywood. Okay, how plywood's, as you said, timber that way, but say for a floor like that you wanted to use or a wall in a house, it ends up being about 9 inches thick if you're using it for a floor. And yeah, you'll have B-class timbers.
I don't know.
I think it's B-class timbers. The sandwich levels all glued together in a pressed compound state, and then you find the top timber may be, hoop pine or something like that, or ash, whatever you determine you want, depending on the manufacturer's part of the world you get it from.
Yeah.
But at the moment, all we can get here is from New Zealand. We're not actually doing it here yet.
Yeah.
Is it waterproof? Because
No.
You look at MDF,
Oh, yeah.
it ends up being 3 times the size if you leave it enough in moisture.
Yes. Yeah.
That was my concern with the exposed edge. I looked at it because of the fact that you got a good insulation material for cold and that sort of thing, but it didn't give me any thermal mass. But then there was this, as I said to the bloke, how do I seal the perimeter of the thing? And he said, we can do it. There's a couple of good houses I can show you pictures of overseas where they've done it. But there'd always be that maintenance factor on that perimeter thing.
Yeah. And the reason I brought up CLT, so I think it's a fantastic technology. But as you said, we don't make it here yet in Australia, and there was the idea to be making it here in Australia, but from what I understand, that idea fell down because we don't get the tensile strength in our timber. So this is probably from Mount Gambier. It's a piece of Pinus radiata from from somewhere, probably in the southeast somewhere there. That doesn't get the same tensile strength that a lot of your timbers that are grown in Europe have, because they grow much slower, colder climate, different properties of that material. That if we go producing CLT in Australia, it doesn't quite meet the strength. So there are issues around that. That's what I heard about that. Anyhow, as to why we're doing so. Yes, the species of tree impacts upon the timber that's produced, but then so does the growing conditions. So that's that's, as I said, a piece of Pinus radiata, and I'll pass that around for people to have a look at. Probably everybody's seen a piece of that. It would probably be the MGP10 or MGP12, so machine graded pine. This, I think that's a piece of Jarrah or Kauri. I'm pretty sure that's maybe anybody knows their timbers really well. They'll tell me. It looks looks like Kauri.
Yeah,
to me.
Kauri.
It is.
Jarrah would be heavier than that.
Yeah. That's what I was thinking. But that's a West Australian hardwood. So your WA hardwoods, either Jarrah or Kauri, are quite hard and quite heavy. But Jarrah tends to be a bit heavier. And so that's softwood versus hardwood. We'll get into that a little bit more later. As a tree grows, it starts with a softwood. It has a pith on the inside, and the tree grows from that pith. And then the oldest wood ends up being in the centre of the tree, and it puts layers on the outside, so it grows out. So that that old thing of I think there was a Gary Larson cartoon of these guys who'd cut down a tree, and you're going, look, son, this tree's like 300 years old. We can count the rings. That's and that's not always the case. Some trees have several growing seasons, so growing periods in a year, or several growing seasons in a year. But that's where that idea stems from, that we get growth rings, because trees grow from the centre, and the new layers are formed on the outside. So those new layers. So from working from the centre, we have the heart, and then the heartwood. So the heartwood, that's the timber that we end up using in the construction. The reason we use the heartwood in construction is because that's the bit that doesn't have all the sugars and so on in it that moulds and insects and so on like to eat. On the outside of the heartwood, then we have the sapwood. That's the wood that conveys all of the nutrients to the tree. So all that's where water and nutrients travels up from the ground and out. Then you have the cambium layer on the outside of that, and then the inner and outer bark for some species. So the cambium is the growth cells, so the wood cells created on the outside, and the wood cells created on the inside, bark cells created on the outside. And then, as I said before, sapwood takes nutrients from roots, leaves, and heartwood is the older wood on the inside. Now, I've passed around those two samples of timber, so our piece of Pinus radiata, and let's just say, for example, that's Kauri, not entirely sure. This one is a hardwood, and you can sort of feel that. You hit it, it's hard. This one is a softwood. I can make a mark with my fingernail in there. That, as a general rule, that's correct, except the correct classification of timber into hardwood and softwood is actually based around cellular structure and not about material properties. One sort of example of that goes sort of against the grain of hardwood, softwood is balsa wood. Has anybody used balsa wood before?
Yeah, I love it.
Yeah.
Very lightweight as well.
Yeah. So for making models, like model airplanes, all that sort of stuff, for mucking around with that sort of stuff, yes, really light timber. So it still has a bit of decent amount of compressive strength in it, not a great deal of tensile strength, but incredibly light. Balsa wood is actually a hardwood. You may be surprised to hear. So hardwoods have a series of cells and then separate vessels for conveying water and nutrients, whereas softwoods don't have those vessels within them. So that's the cellular structure of a softwood, and this is the cellular structure of a hardwood. So your balsa wood, although it's quite light, very compressible, and so on, not very hard, comes under the classification of a hardwood. Also, your softwoods will have that central pith, on the inside. So you cut down a pine tree, there's this central core in the middle there. It's a pith. So our species dictates how the timber, or what quality the timber are going to be like, and our climate also dictates what the quality is going to be like. But another thing that dictates how a piece of timber performs is from where in the log it is cut. So here we've got what's called quarter sawn, and that's a quarter sawn hardwood, and that's a myrtle burl. So does anybody know? Has anybody seen a myrtle tree before? Anyone been down Tasmania, walking through the forests in Tassie? Yeah. So you've got, so particularly down in places like Tasmania, you've got these giant myrtle trees that grow there. They're native to Tasmania, and they get these big lumps on the bottom of them. I'm not sure actually what causes the burls on them, but those big lumps are the burls. And then you shave those burls, and you get this really intricate pattern in your timber. So there's a lot of high feature grade of that timber in there. So that and for anybody who plays wooden instruments or has looked at wooden instruments before, also you'll see things like these sort of veneers for sections on instruments, but also all your cellos and double basses and or violins, etc. All your necks are going to be made of quarter sawn. Actually, it's not quite. So I was speaking to a double bass maker about the grain and the way it works in a neck. It's slightly offset, but for intents and purposes, quarter sawn, because that's the most stable section of timber from a log, and we'll see that in a minute. Another important aspect of timber to consider is its drying and its shrinkage, and how quickly you can dry out that piece of timber, whether that has to happen over a very long time or has to happen it can happen very quickly. Like this stuff, for example, that can be dried very quickly. So that's done in a kiln. So they'll chop it down, they'll put it into stacks, put it in a kiln, and kiln dry it. Whereas your hardwoods, you don't. Well, these ones, they have to dry over time, so over a much longer time, so it adds to the expense of them. And of course, that drying, the timber loses its moisture, and it will shrink, and depending on where that piece of timber is cut from the log will dictate the shape of that piece of timber that results from the shrinkage as well. So strength and hardness is also important. Durability of timber is also very important to consider. So something like this, yes, you'd use that. Well, actually, no. You can do decks with Pinus radiata. You can do a deck outside with Pinus radiata, or you can do it with a WA hardwood. Or a lot of decks are done with Mabau from, I think it's from Indonesia. Is it Indonesia or Malaysia? Yeah, but yeah, one of the two. So what's that?
It's ruining their forests.
Yes, exactly. Yeah, so it's a rainforest timber, and that's also another thing which is very important to consider is where the timber comes from. What timber comes from trees. Trees are cut down. How is that harvested? Is that harvested in a way that's sustainable or responsible? And or is not.
Just ask the orangutan.
Exactly. Yeah. But if let's say this is Jarrah, right? And I do a deck out of Jarrah. That is going to last a lot longer outside in the weather than if I do the deck in Pinus radiata. This will not last very long in the weather using the same size bits of material, cross section, etc. Doesn't quite have that same durability, and so because of the species of timber and the way that it's grown, there is different natural durability of timber, but that durability can be enhanced as well. I don't have any LOSP in here. Oh, unless this is no, it's not LOSP. You may have seen sometimes you've got timber frames go up and they're this light or this blue colour, this sort of blue tinge. It's not what I'm talking about. There's actually another type of timber coating you see on timber, particularly when it's used for fascias, which is a lighter sort of baby blue colour. Has anybody seen any of that timber before?
I've seen it, but I'm trying to get where you're going.
Yeah, okay, so that light baby blue colour timber, that's LOSP.
It's
So,
normal Pinus
was
radiata.
that?
Isn't it just Pinus radiata trees?
It's Pinus radiata, but it's treated with light organic solvent,
Okay.
with LOSP. That makes it durable to be used outside. So if we just use a piece of this as our fascia behind our gutter where moisture collects, then that won't last very long. But if we treat that with LOSP, then it will last a very long time. So the natural durability of this piece of timber is not very high, but if we treat it, then its durability is high. That's the difference between durability and natural durability. So in drying our timber, obviously when the tree is cut down and it's a growing tree, the cells are fully saturated with water. That's considered to be 100% saturation of water. And to season our timber, we get down to I think it's around the 17% water saturation. We'll flick through. Yeah. Well, in here we've got seasoned timber at 25% moisture content. I might just check that as we go through. I thought seasoned is typically slightly lower than that, but I'll go with this. It's wood solution. So seasoned timber at 25% moisture content. So drying the timber increases its strength and its stiffness. So once you extract the moisture out of the cells, they become more rigid. So they're stronger and stiffer, and it's also more stable, because as timber loses its moisture, it changes slightly in shape and size. I've seen floors in houses that have had a lot of moisture underneath, and those floors have bowed up as a result of timber wanting to expand and pushing up as a result of that. Also, timber's more durable once it's been seasoned, because it doesn't have because the water in there is a conduit for the sugars for molds and insects, etc. And it's much easier to fasten, where you get a much better fix. If you nail into a piece of unseasoned timber and then that timber seasons, that nail is not bound into the timber as well as if it was just seasoned timber and you nail into it. Now, see if I'll show this one first. So of those two slides, as I was talking before about quarter sawn, so cello necks and whatnot, that's this piece of timber here. And so the reason that a quarter sawn piece of timber is a desirable piece of timber is because when it loses its moisture, it stays basically the same shape, because shrinkage in a tangential shrink sense differs from in a radial sense. So our radial shrinkage is across the radii of the rings of the tree, so the various different radii within a circle, and then the tangent is in a longitudinal direction along the radii. So if we look at a piece of radiata pine, its radial shrinkage is 3.5% and its tangential shrinkage is 4%. So there's not a great deal of difference there. So we chop a piece of timber out of a log sort of anywhere within a piece of pine, it's going to be relatively stable in its shape as it dries. So it's not a huge issue. But we get a piece of kauri, and its radial shrinkage is 4.5%, but its tangential shrinkage is 10%. So if we chop a piece of timber just anywhere out of a log of kauri, it's going to deform as we dry it out. So from our piece of kauri, if we get a quarter sawn piece, it's going to maintain its shape. Whereas if we cut a piece from up the top here like that, it'll cut significantly.
So once it loses its moisture,
Mm-hmm.
does it ever have a coefficient of expansion with temperature?
It certainly would. I don't know the answer to that though. Yeah, I don't have any information on that. Yeah, it certainly would have a coefficient of that take up of moisture again and the reactivity to it. I don't know. Yeah, I don't have any info on that. That'd be a great thing to see like this as well. So we've got our shrinkage as they season. Yes, another thing here.
It's obviously not very important because like metals and concrete all their coefficients always listed.
Yeah, because they're a manufactured product.
Yeah,
maybe as well.
Depend on timber too. So,
It does.
obviously pine would, being the cell structure of the pine, would suck a hell of a lot more than say dried.
Like teakwood.
Excuse me, red
Yeah.
gum.
Yeah.
I slabbed a red gum that me to you, running off my property last year, and it had blown down, but it had been dead for like probably 50 years. When we cut it, there was still, what do you call it, like it's blood.
Sap.
Sap, in the centre, and it had been dead for years. The bloke that slabbed it, he went from pain slabbing it, but he said that's going to have to weather for at least 2 years before you can make tables out of it. And he said, but I put some out as just seats and stuff in the paddock, and like the water just runs off it.
Mm-hmm.
It doesn't suck in at all.
Yes.
It's amazing.
Yeah. And so, although I don't have any information on that take up of moisture, it is still something that's an important consideration in construction, though. So what you should never do is build a deck outside with all your decking material going right next to each other. You always have to leave that 5 to 8 mil gap between your decking slats for that expansion. So as it takes up, what's that?
Make sure you put it round.
Oh yes. There's that thing as well. I
You've seen it.
Yeah, I don't have a piece of decking material in here. But yeah, what Doug's referring to is you got I forget what it's called now. The scribing on the back of decking for creating moisture, for making moisture drip.
Yeah.
That should always go down. Some people place it up. Anyhow.
Architectural, mate.
Yeah.
It's
But,
not
yeah.
architectural.
But anyhow, so your various different timbers have various different rates of shrinkage for both the radial shrinkage and the tangential shrinkage. And so that has an impact on how those pieces of timber should be sawn, and then what the properties of that timber is going to be like once it's seasoned. And so within this diagram, we can see how the various different pieces of timber cut or from the various different positions in the log will have their shape impacted. So if we get one, so in these sections here like this, where we have the radii going in an oblique fashion, then they tend to bow and cuff and twist and whatnot. Pines have a porous cell structure, hardwoods have a non-porous cell structure. The moisture diffused through the cell wall, drying in hardwoods can be very slow, and it has to be done carefully. Also, the cell structure is important, or how the cells run is important for strength of timber as well. For anybody who has a wood fire, you'd know that splitting wood along the grain is really easy. You can't split wood across the grain. Now you place your logs like this, and you split them from top to bottom. You don't lay your logs down on the ground and try trying to chop through them, right? That's timber is very strong in both that compression and tension sense, but it's weak perpendicular to the grain. So those grain, the cells in timber can be separated very easily. Timber is a natural material. Each piece is unique in fibre texture and colour. Sometimes that's important to us, sometimes it's not. If I'm building or designing a house frame, I'll specify, we'll pretty much always specify MGP10. So timber has various different stress gratings. MGP, that's specific to pine. So that MGP stands for machine graded pine. If I was to go down to a timber supplier and just get some machine graded pine, I'd probably get MGP10 or MGP12. They might have either one in stock in the size that I want. But if I'm designing a house frame, I almost exclusively design it with MGP10, because if the supplier happens to have MGP12 instead of 10, well then it's gone beyond the strength that it was designed for. Whereas if they've only got MGP10 in that size, well, it's been designed for MGP10, so that's fine. So if you go designing frames using the timber span tables, I suggest just use the MGP10 span table, and then if you get some MGP12, well then that's good for bonus. Just slightly greater compressive strength and I guess slightly greater tensile strength as well. If I was to look at a
load bearing.
Yeah. So the way that you go about designing frames is, so it's within reference to AS 1684, which is the timber framing code that tells you how, and we'll get into that next week. That tells you all of, all right. So each piece is unique in fibre, texture, and colour. So for this stuff, I don't really care, right, how unique this piece of timber is. Although what I do care about are things like that. That's a live knot. That one's not so bad. That one with the dark bit around it was a dead knot. That one is bad. Because the dead knot is not bound to the timber. And so the strength of this piece of timber is just simply these bits that's on the side. So that dead knot has fallen out because it's not bound to the timber. That one's a live knot. So when the tree was cut down, that branch is still alive. And that's bound to the timber. That's not going to compromise its strength significantly. Although you should, particularly when you're attaching bracing where you've got point loads and things like that, still be aware of knots, etc., because it is going to be a compromising of the strength. But by and large, I'm not too concerned with the unique properties of that, of that particular piece of timber for framing. But for some of these other pieces of timber that that I'll be using for second fix carpentry, for skirting, architraves, things like that, the unique features of this piece of timber are important because they get seen, and any of the variations can't be easily hidden as they can be behind sheets of plasterboard for your walling. It takes up and gives moisture, it expands and shrinks, does so, and deteriorates in line with exposure. So we can treat timber with various different treatments to increase its durability, but then there's also a bunch of things we can do to help that piece of timber be more durable. One thing is a post stirrup. So rather than just having timber posts go straight into the ground where they'll rot, or straight into concrete, which will shrink away from the timber and be a place for moisture to gather and then also slowly rot the timber, we can use a post shoe on the bottom. Has everybody seen a post shoe on the bottom of a stump before? Yeah. Some. Unfortunately, I don't have. Well, I do have one to bring in. I didn't bring it in, but I'll just quickly Google search an image. Okay. Yeah.
Only put timber post shoe.
Yeah, I think so. Yeah. Yeah, yeah. Either one, or either of these three. This one or this one are your typical. These ones are slightly more expensive to buy. That's your Cyclone tie down post shoe, but they get used a lot here, even though they
I
don't
thought
have.
you were talking about something in red. Yeah, I've got those on my brand.
They
Yeah.
work really well at the beach.
What's that?
They work really well at the beach. Like the timbers just end up hanging in the middle of nowhere.
Yeah. Oh, yeah, yeah.
So,
Yeah. But yeah, you got your various different post shoes and stirrups. Oh, so that's a pretty common one. They'll get cast into concrete, but also yeah, so this type here are very common as well, particularly with long legs on them as well, so you can cast them into concrete. So you do a concrete footing and you cast it in, but they've also got the accommodation for drilling through and dine bolting on the top as well. But this type of post stirrup, that's more for high wind areas, but they're also kind of handy for they're a nice way of fixing anyhow. And so those ones are really quite common. This type is not so common. That's a little bit more architectural. I've never installed one of those, but you certainly see these about a bit.
On my current house, I've got those out the back, because it's like a colonial sort of thing out the front. You can also get cast aluminium Federation style
Yes.
ones.
Yeah.
And I've got those out the front.
Yeah.
And they're like they're into the cement like that, but they've got a lovely Federation type.
Yeah, a little foot on the on the bottom of them. Yeah, and that's also something you see a lot to dress up the base of the timber. So that sort of thing, that's going to increase the durability of the timber because we're getting it up off the ground. And also for termites, we have to ensure that any of our timber members are at least 75 millimeters up off the ground so that we can see where the termites are making little mud nests to burrow up to them to eat them. So timber is available in a wide range of products and species, including solid sawn, moulded and laminated timber, veneers, plywoods, and wood panels. So that's our piece of solid sawn. Piece of sorry, that's a piece of plywood with a good veneer on it. No, I don't have any. No, I don't have any bits with a good veneer on them. Yeah, can anybody think of applications for timber with veneer on it?
Car dashes.
Car dashes, yes. The English vehicles.
Cars you used to see timber veneers all the time.
Yes,
it's almost always interior doors.
Yeah.
They're only hollow.
Yeah.
They're mostly fascias within houses. Where you've just got trim work.
Yes. Yeah.
Inlaying.
Soft version.
Yes.
You used to see walnut burrs and those sort of things in
No.
the old days.
Yeah. So a lot in furnishings. Yeah.
Very cheap these days.
Yeah. Plywoods. So plywood, very handy sort of stuff. Because of the structure of plywood, because you've got grain running this way, and then grain running that way for the next layer, and then this way again, and for that way again. I'll pass it around for you to have a look at. It ends up being a very solid, stable, strong piece of timber.
Why is it so moisture resistant?
Why is it? How does it become so? Actually, I don't know. Don't know the ins and outs of that. But you do have some plywoods which are more moisture resistant than others, though.
It's got gaps and holes in it where water can get in, and it doesn't seem to
It's
affect it.
all those layers are glued together.
Yeah.
And the glues in your incline are what predominantly will.
And then also, something you don't see too much in modern construction, but also wood paneling as well. So something that was a bit more popular in the 1970s. So what I'll do is I'll stop that just here, and just while I've got, actually what I'll do is I'll bring all this timber stuff back next week as well for you to see the various different timber products as well, so we can see some more of those things next week. Okay, so I'll stop it there. So we're halfway through timber the material, and I'll just pause the recording.